Well, welcome back from lunch. I hear there's some serious networking going on down below, which is an important part of this day as we get the industry together and talk about things of common interest. Before I introduce our keynote speaker, I'd just like to make mention of two people who are not here today. If you came to this event 2 years ago, we had a wonderful keynote presentation by Michael Crouch of Zip Hot Water. And Michael passed away some months ago, and we should just acknowledge that. Also, a gentleman by the name of John Vines was not here. John was the founder of Auspex Piping. Glenn, his son, is here, who still carries on the brand responsibilities under the Reliance banner. And I was fortunate to go to John's funeral just a couple of weeks ago, and Alan Wilson from Reese gave a lovely eulogy. So condolences to both those companies and the families. It's now my pleasure to introduce our keynote speaker, Professor Stuart White, who is the Director of the Institute of Sustainable Futures here at UTS, the University of Technology, Sydney. I first met Stuart only a couple of years back when we were both on a program at the Emerging Water Technology Symposium in Chicago, an event that's initiated by the IAPMO group. That day, Stuart delivered a great presentation on Australia's decade of drought and the experiences gained. Now, previously, we've had some of Stuart's senior project team address us at Plumbing Supply Forum on some tasty technical topics like urine diversion. But today, it's great that we can have Stuart here to share his worldly view of the sustainable future and just where the plumbing sector links into that. Would you please welcome Stuart?
Thanks very much, Jeff, and thanks to you and the organisers for the opportunity to speak. It's been great to catch up with some people I haven't seen for a while, and also to hear those really informative presentations this morning, which I think set the scene quite well. I'll be probably talking at a futures level, so I want to particularly focus on the opportunities that we might have and the disruptions that may come in the future. And also just to talk a little bit about what we can learn from other sectors. I mean, at the Institute for Sustainable Futures, we work across a number of different infrastructure areas, a sort of a common theme about working towards sustainable futures. And there are some lessons, I think, for the water industry from other sectors that I'll just dwell on briefly just to illustrate the points. And also, talk about some of the experience from some of our work in different places. And some of those places shown here, the work that we've done in various jurisdictions, obviously in Australia, and particularly during the Millennium Drought. We were extremely busy with a whole range of different water efficiency programs, working for government regulators, utilities, and the private sector. But in terms of the presentation, I wanted to just talk first about what is it that is the goal in terms of sustainability. What are we chasing? How do we know whether we've succeeded in what we're trying to do? And of course, our mission to create change towards sustainable futures is deliberately towards. It's not something you can ever reach. It's a direction. It's a nudge. It's trying to move things in that particular way. And secondly, just talk about, well, how do we vision the future? How do we make sure that we are trying to create a future that we can then work each year by year towards? Then lessons from other sectors, as I said, and also just a bit of crystal ball gazing. Might be dangerous, might be a bit arrogant, might be a bit foolish, but to just cast an eye to what we might be seeing down the pipeline, as it were. But firstly, there are a few things that have changed in the last few years. I mean, one is that we've reached 190-something countries have reached an agreement in terms of the Paris Climate Agreement. And for all the criticism that that particular agreement has generated, it actually is an agreement to move forward to try and have a goal of reducing the impact on global temperature through CO2 emissions. And that is determining a whole range of different actions. It's one of those sort of 3 steps forward, 2 steps back cases. But perhaps I think a quiet achiever is the Sustainable Development Goals. The 17 Sustainable Development Goals replaced the Millennium Development Goals, which had come to the end of their time in 2015. And again, over 150 countries around the world have signed up for these, including Australia. And one of the changes from the Millennium Development Goals is it is seen clearly to apply to high-income countries. So it's not just about low-income countries, and it applies across a much broader range of parameters. I mean, you might think 17, that's too complex, it's let alone the 264 indicators, but it actually is a very strong foundation, and it's being taken seriously, not just by governments around the world, but by the private sector as well, and certainly by NGOs. So this is the sort of backdrop in which we're operating. The second thing is visioning the future, and a lot of our work looks at megatrends, and we often think of megatrends as being the really negative things, the things that cause you to stay awake at night in terms of climate change and global poverty and so on. But in fact, there are just as many megatrends which offer us opportunities for hope. We heard about some of those this morning, the advent of Industry 4.0. I'll talk a bit more about that later. Some things which will increase the potential for the pace of change towards solutions. And we mustn't forget that those kind of non-linear trends that we often think about as being a bit of a downer can actually be positive megatrends, positive non-linear effects that can lead to solutions just as easily as they can exacerbate problems, while remaining aware that there are some serious issues that we need to address. And so a lot of our work that we've done for different utilities, for example, our work originally for Sydney Water. Sydney Water was, as you probably, many of you will be aware, was given an operating licence target to reduce water consumption per capita by 25% and by 35% within a reasonably short period of time, which focuses the mind. If you can lose your operating licence if you don't meet that particular target. And so we were asked to determine a strategy to meet that. And so we employ a method called backcasting, which is to say, well, if you want this outcome in this forward year, and you then have to work backwards to say, well, what do you need to do 5 years before that in order to achieve that outcome? What do you need to do 10 years before that? What do you need to do next year in order to have achieved that goal? Hence the image of the Harbour Bridge. And that's a method that we often apply. You just determine the vision, you determine what you want in the year 2030, 2050, whatever it might be, and then work backward to say what would need to happen. So to recognise that trend is not destiny, we actually have a chance. And usually they're institutional and political arrangements that are actually the problem. It's not the technical issues. We usually have the technology, as they say, whether it be energy, water, transport, waste. We usually, it's economically effective and efficient. Usually it's just the institutional arrangements, the rules and regulations that get in the way of achieving those goals. And a lot of our work, therefore, is focused on those rules. So that's my introduction over. Happy to take any questions about those broader issues. But I now want to just say, and quite quickly, because I don't want to get into the details about the electricity industry in an audience that's much more concerned about the water sector, but I think there are some things we can learn. And a lot of our work that we've done has been looking at the dramatic changes that we've seen. I mean, we're in the middle of dramatic changes for the utility and electricity industry, for example, just leaving aside the other energy, gas and liquid fuels. But in the electricity sector, we're seeing massive disruption. And many people didn't foresee it or didn't foresee the speed with which it would occur and the impact on the utility sector. And of course, in Australia, while we have had some significant reforms, we didn't necessarily anticipate in setting up the competitive electricity sector what that might mean down the track when it completely transformed. Some of our work has been looking at some of these issues and indeed producing the Australian Decentralised Energy Roadmap, which looks specifically at the role of energy efficiency, peak demand management, transport of electricity is about half of the cost of the entire sector. So it's not the generation or the retail, even though the retailer sends you the bill. It's not the generation, even though there's a lot of argy-bargy in the media about Liddell and Snowy 2.0 and so on. It's not the generation. It's actually, well, half of the cost is actually the distribution, mostly the distribution, not even the transmission, the distribution, so the last kilometre or 3 of the getting the electricity. Now think of the metaphor, or the analogy, I should say, with water. So we're increasingly seeing that the cost of the transport of the water and the wastewater that's generated is where the costs are. So we can learn something from the telecommunications industry. There are many countries, low-income countries, that have completely leapfrogged stationary telephony. They've gone straight to mobile telephony at much lower cost. They don't have these legacy systems, all that copper and the arguments about NBN, copper, so on, fibre. They've just gone straight to mobile telephony and have quite ubiquitous ownership, high rates of ownership, good communication at much, much lower cost. So we see an analogy there. We see in the energy sector, well, let me give you another example. I mean, in terms of disruption, I don't know, hands up those who ever owned a BlackBerry. So, and you see how rapid was the change with RAM sort of disappearing from the market, because while being a dominant smartphone, it failed to meet the consumer demand, which was actually for the applications, the thing which sat on top of the phone infrastructure. And we're starting to see, as I was alluding to, the disruption. There are a couple of different disruptions. I'll just use these as illustrative points so that we can then talk about water. But we've seen the decline, rapid decline. This is an old graph. It's gone down even further now. The cost of solar photovoltaics, which has completely changed the industry. The second one, which we're just seeing the beginning of, in Australia we're a laggard, of course. We don't have a good policy environment. The market's not as good as it is elsewhere, such as Norway or other countries, China, and so on. But we will see very shortly, and this is a prediction I'm comfortable making, we will see a massive change in both the sales and therefore flowing through to ownership of the stock of electric vehicles, including combinations of battery electric vehicles, plug-in hybrids and so on. And it's interesting to consider that if you ask how many plug-in hybrid electric vehicles would be Australia's total peak electricity demand. I won't do that as a quiz because we probably don't have time to do that exercise, but it's actually about 800,000 vehicles. So that's sort of 6% or so of the fleet. So it's a very small number of vehicles relative to our fleet which actually have the same capacity, engine generative capacity, as our entire peak electricity demand. So the implications of that for within the electricity system, both in terms of grid-to-vehicle charging, but also particularly vehicle-to-grid supply and peak demand. And if you combine these two, the disruption, if you combine these two, and we could either do this well by making sure that the charging regimes suited the existence of photovoltaics and a mobile storage system where the batteries come free with the vehicle, in the sense that people are buying the vehicle for its mobility, and the battery ability to provide energy into the stationary grid system is a free good, which they can then get paid for. If you combine those two things, then that's a good outcome. If we just have willy-nilly charging without any such controls, then of course we'll have a very bad outcome. So if you combine those, then you get some significant disruption. Now the next disruption is one that might not seem so high-tech, but in fact it is, and it's extremely important, and it has profound implications also for the water sector, is the ability to empower consumers to have control over their consumption and use. And we're starting to see the emergence of this in the US, the Green Button platform, There are other vendors in the market, and they're starting to come to Australia. A lot of Australian startups are playing in this space. In fact, Australia's a very rich place for the startups in this sector, and I think we should look forward and towards when we see the same innovation ecosystem support in the water sector. So we've seen startups, Solar Analytics, GreenSync, Reposit Power, Watt Watchers, Watt Cost. There's a whole range of small, medium startups and scale-ups that are working in the area of how to provide information back to customers about their energy use and what they can do about it and how they can reduce it, including special deals and but also what they can do to improve their energy efficiency and reduce peak demand in particular and get paid for it. Now, of course, the analogy is not perfect with water. I mean, peak demand is an issue in the water supply system, but it's not as great an issue as it is in energy. But the consumption piece, the control for leaks, the asset condition monitoring, the integration with BIM. When I was listening to John talk before lunch, I thought, this is an amazing. We're on the cusp of the potential for integrating BIM with asset monitoring for a whole range of assets, right down to the appliance level in terms of water. So we look forward to that. And the other dimension of that, of course, is then the feedback to home automation. It's no coincidence that companies like Apple, Google, Samsung have all got their different platforms, HomeKit, Nest. They've made acquisitions to position themselves for home automation. They will be the next energy utilities, not the big energy companies that we know and love, but it'll be these companies because they'll have access, as Google always does, to the data and will use it for fun and profit. So we will start to see that being the new model. And so the question is, what does that mean? What's the next step? Because water's probably the same with a sort of a 5 to 10 year delay, getting shorter all the time. So change is coming. There's no question. It has already come to the energy sector. It is coming to the water sector in a whole variety of ways. And we've of course heard some of that, about some of that this morning. And so I just want to now switch to talk about the urban water sector. And again, there's probably, for many of you, not particular insights here, but just perhaps the aggregation or collection of those, of some of the things. And we've heard a fair bit about what I would regard as one of the most important, which is the role of water efficiency and the importance of water efficiency in the sector. And many people in the audience have contributed significantly to this over the years. And of course, there's probably no better example of that than the water efficiency labelling scheme that we heard about from Carol and from Stuart and others, and how important that's been and how much leadership Australia has shown. And even, the dual flush toilet, the work of Coroma and in putting that on the map, so to speak, has been a significant contributor. But we look at the whole range of different appliances. Every single appliance category or water end-use category, whether it be cooling towers, whether it be urinals, whether it be toilets, washing machines, dishwashers, we've seen that absolutely dramatic reduction in the amount of water that's required to get the end use. And our approach in this work has always been, it's not the water that people need, it's the same as it's not the electricity that people need. They need the services that are provided by that water or electricity. And the sooner, we always have argued to utilities, the sooner that utilities realise that they could be in the service business rather than the selling low-cost commodity business, the sooner that we'll actually be on a better situation, both in terms of the sustainability, but also in terms of the economic viability of those very utilities. Because otherwise they won't see the disruptions that we've just seen in the energy sector. And of course that message was heard, and it was luckily heard during the drought. So we saw some fantastic reforms and measures, and Australia did truly lead the world in terms of responding to the millennium drought, both in the ag sector as well, but particularly in today's context in the urban sector. So that leadership, as we heard from Stuart and Carol, was extremely important. And on that score, I just wanted to make a quick public service announcement. We've been privileged to be commissioned to provide a review of the WELS scheme in terms of its benefits and impact. And Anna Schlunke's in the audience, Anna, there, from the Institute, and she's really keen. We're really keen for any stakeholders to contact us to talk to us about WELS, and so Anna is working with others. The project, of course, Carol, in terms of on the client side, on that project. So apologies for the taking time out for that public service announcement, but I think it's quite a timely look to extend some work we did previously reviewing WELS. But WELS has been a great success story. We have added 1 million people to the population of Sydney and not increased the demand for water. Now, WELS alone is not the only contributor to that. There have been other factors, but we've seen the same pattern around the world. In fact, so here we see population and demand flattening. We see the same here in Germany. Interestingly, the new federal states, which are the former East Germany, an even greater decline. In this case, it's litres per capita per day in the residential sector alone. See how low these figures are, but see how much lower they are for the new federal states. Why? Because of the rapid changeover and renewal of the housing stock, and the fact that new appliances and fixtures were being installed in that housing stock, which meant that they were even more efficient than even the old former West German housing stock. So we see that same pattern. And you all know why. I apologise almost for this slide because it's so obvious to all of you in terms of your work, but the change in stock from the introduction of the first dual flush toilets means that we will never use as much water flushing toilets as we did in, oh, it's hard to see there, but it's sort of roughly 1992 or so. We reached peak flushing, and we'll never use as much water in toilet flushing as we did then, no matter how much the population grows, because the toilet manufacturers don't stop. They keep working on even more efficient models. And we see this, some of you might have come across this notion of a Kuznets, which is the idea of low-income countries reach a level of affluence, and in doing so, they increase pollution output and then reach a point where they can afford to spend money on environmental controls and pollution controls and so on, and come down the other side. Now, there are some serious philosophical objections to this model, and it need not be so, but you can apply the same principle, and we have seen this occur, as I say, across the world, where the consumption of water, energy, materials used per capita increases and then starts to, we reach a peak, plateau, and then decreasing. We've seen it in oil, we've even seen it in vehicle kilometres travelled, in transport. We've certainly seen it in energy, so energy kilowatt hours at least have plateaued and reducing in the residential sector. And we've certainly seen it in water. It's quite extreme, actually. And so one of the questions we have for our work, which we do in low-income countries, is whether we can actually just tunnel through this Kuznets curve, not go through all the fuss and bother of installing inefficient equipment and appliances, which then generate more wastewater and cost millions of dollars per megalitre per day, and so on. We could just cut to the chase with an efficient system to start with. And one of the ways that we would do that is to think in systems terms, and I'll come back to that very question. Because water efficiency is the single largest, quickest and cheapest contributor to new water, and this is just the work that we did some years ago for Sydney, which showed that the 145 gigalitres per year, which comes from water savings, is the largest single contributor to new water in Sydney. It's the quiet achiever, if you will, or the negalitres, another way of expressing it. And again, looking at other countries, low-income countries, and we see that if we look at a future transition from pour flush latrines, from manual showering, from manual clothes washing, to more efficient, as people and we've observed this in many peri-urban areas around the world, as people do gather fixtures and appliances in their premises, if they're not efficient, we face the worst case outcome, which is this growth that you see in the left hand of the three graphs. If we put in efficient, best practice equipment and fixtures and appliances, then we see the reverse. We can actually reduce over time the water, even relative to manual use, which is quite a telling lesson about the importance of these kind of regulatory standards in low-income countries as well. So that's enough about water efficiency. Or you can never have enough about water efficiency, but for now, let's turn our mind to perhaps the bigger issue, which is the water infrastructure system itself. I mean, we've constructed the human water cycle from three different components. From a pressurised water system, which actually originally was put in place in order to prevent or to help with fire management. A stormwater system, which was put in place to prevent flooding, and a sanitation system was put in place to prevent cholera and disease. And so we started with the first generation unmanaged, decentralised, and interestingly, these parallel the four sort of industrial periods, and I'll show shortly a chart which shows the evolution to Industry 4.0, and they're quite analogous, and you can have a similar analysis that we've done here for water for the electricity sector, and possibly for others as well in terms of transport and so on. But we see the original sort of unmanaged, unplanned, and there were significant public health consequences, which is why ultimately the Chadwick Royal Commission in the UK, I mean, it was partly because the smell coming into Parliament House in London was such that something had to be done, but it was also because of the economic impact of workers dying of cholera. So the first sewers were constructed, and in the top illustration, the beautiful sewers of Paris. Highly recommended if you haven't been to have a look at those. And of course the large centralised water supply systems and so on. And such was the commitment to this that in Chicago, the bottom photo is the whole city was lifted in order, they couldn't build the sewers underneath the existing city, so they actually lifted the city, lifted all the buildings in order to build the sewers underneath when they constructed the centralised system. So what it did is it protected the health of people in the city, but it pushed the problem away and into the lake. In the case of Chicago, further out into the lake, and in Sydney to Bondi and so on. So we then had the third generation, and this was the environmental protection movement to say, well, this is not good enough, we can't just be pumping raw sewage out even if it's some distance from where people live. Soon people wanted to live there because it was nice to be there, Bondi, and so on. So we had not in Sydney for a long time, I'll admit, in fact, yet, ever, but in other cities, we had a move to put end-of-pipe systems in order to improve environmental protection. So we spent a lot of money, obviously, and a lot of energy, a lot of chemical energy in order to improve that. So then we're now starting to see, and part of this is driven by innovation, part of it's driven by an awareness of the costs associated with that existing system, part of it's driven by community interest and by the development sector, Green Star. There's a whole range of different reasons that come together for what we call this fourth generation, emerging generation of urban water service provision. Deliberate choice of word, service provision. So we're providing the services that people need. And so we're starting to see an interest in source control. We heard earlier, I have to mention urine diverting toilets, which you see one on the top left there. Urine contains 80% of the nutrients in human waste. It's very easy to collect. And in some municipalities, including the reasonably large city of Malmö in Sweden, it's becoming required in new developments. So it's an emerging phenomenon, the yellow pipe. And We see the water garden in Santa Monica, where the lake there is actually reclaimed water, Potsdamer Platz, the stormwater system integrated with landscaping, and Central Park, which I'll come to. So we're seeing advanced water efficiency, source control, starting to recognise that with vacuum toilet systems we could be both reducing the water use but also capturing the carbon and nutrient and other value, energy value of the waste in a vacuum system, co-mingled with organic waste, food waste, which is now emerging as the significant residual problem in solid waste disposal. So you see a perfect solution there, which we're looking at very closely through a vacuum system. And also, obviously, source control of nutrients, but recovery. What's the point if we have to treat the water to such a high standard in order to put it into the marine or the aquatic environment, which is, say, in Sydney, South Creek. South Creek suffers from phosphorus. If we're going to put another 1 million people there in that catchment, then we have to clean the water up even more. To get that last 0.1% is going to cost us an arm and a leg. And if we're going to do that, why don't we just reuse it? Or more, reuse it more, and reconfigure the system in order to do that. Because as soon as you start to send it out, bring it back, treat it again, send it out again, then you can see where the cost goes. We're adding a significant cost. Whereas if we do that in a more localised way, we'll save the cost of treatment, we can spend more on, save the cost of transport, we can spend more on treatment. So you can sort of see the picture here, and of course I've put a token smart meter up there to point out that the digitalisation of that whole process, including telemetry and controls, is quite going to be quite significant and important. Fourth generation in practice, many of you are familiar with Central Park, which is just opposite our campus. We have pride in having the ugliest building in Sydney, the big brown one. Brutalist, the perfect example of brutalist architecture in the 1970s. And the award-winning so-called best tall building in the world in 2014 is opposite us, which is One Central Park, with the green wall designed by Patrick Blanc. But more significantly is what's hidden is the 1 megalitre per day wastewater treatment plant in the basement, which recovers, reuses wastewater, treats to a high standard for use both for the irrigation but also for toilets, cooling towers, cold water wash, cleaning, and the cooling towers, yeah. So that's an example. It's integrated with the central thermal plant, which provides the heat, and rainwater is collected from the roof as well. So this is an example of fourth generation practice. In fact, there's a 6 megalitre per day sewer running diagonally under the site, so it's not like we needed to do this in order to provide sewer capacity, but it does provide an example of what you could do if there was a sewer constraint, or if we wanted to start to slowly reconfigure the system over a period of 50 to 100 years, which is probably how long it will take to do that. With energy, it's much quicker. You can get the grid to operate to your demand. So that's Central Park, and I can certainly commend that to you. There's more information online. So what we're looking at is the potential that this fourth generation is actually a lower relative cost per household. This is an open question, and obviously it depends on the context critically, but it might be that if we can spend less on transport, if we can actually put more smarts, so more brain, less brawn, into the whole water system, we can actually start to reduce the costs from what we've been historically doing. If we threw the variables up in the air and saw where they landed in a much more efficient way, then we would have a different configuration. And so we heard from John about the 3D and the 4D and the 5D and the 6D. Well, it's an ND system of systems, if you will, where we look at the water, the energy, the carbon, the nutrients, livability and productivity of the system. And again, from a systems point of view, historically a utility has seen its boundary. We supply water, we do so as a public service at the least cost, and we supply it to the customers, and at the end of the meter, that's where our responsibility ends. But in order to get the best outcome for society as a whole, we need to the utilities need to say, no, our business actually goes beyond that to the customer's premises itself, past the meter, even to the equipment and fixtures, they're part of the system. If we don't consider them part of the system, we'll get the wrong answer, because the answer will be just build another dam or another desal plant, and she'll be right. Whereas if you actually think, no, well, we could actually, the appliances are part of this, so let's fix them. And then the practices and processes, how people use those. We realise now that the limits of efficiency of toilets is now no longer governed by the bowl. I think Steve's done the best he can with that. The next step is actually the system itself, the grades, the configuration, the fittings and so on, and even the paper that we use. And the way we use the toilet paper, that actually makes a material difference. And some of the new wastewater treatment plants that have been installed in different parts of Melbourne, in buildings, have actually got different results in different areas of Melbourne depending on the kind of toilet paper that's used. So, true story. And then, of course, there's the interconnection and feedback that I said. And there's a revolution that's occurring in the cost of sensors for the Internet of Things. And we've been a bit involved in this because we installed one of the first LoRaWAN nodes on top of our building, which is free for anyone to connect, so there's no Telstra fee or anything like that. And that will revolutionise because you can have, it's very low power, means the battery life can be extended from months to years for many sensors. So the ubiquitous and low cost, the ability to apply sensors in a ubiquitous and low cost way will revolutionise the Internet of Things in a way that will enable a whole lot of possibilities in the water sector that were no longer, that weren't possible before. So that's another aspect which is summarised here, Industry 4.0. This is from some work from Accenture, but you can see that the water sector is probably just on the bottom left there, coming into this picture, and we will see it very soon, I think, appearing in that particular picture, getting close to the end here. And we can see the industry 1.0, 2.0, 3.0, 4.0 being perfect in lockstep with the generations of infrastructure that I talked about earlier. And so in a sense it's an application to the water industry of this same principle. So lots of different possibilities for the sector, many of them driven by this kind of changes, but also many of them driven by just the fact that we are historically here with a multi-billion-dollar set of assets that are beneath our feet and in our buildings and so on, that are hard and slow to change. But if we actually think about it from a futures visioning point of view, we can probably get ahead of that game. There are certainly opportunities for us to move quite quickly to that. So with that, I might leave it, and I think I may have some time for questions. Is that right, Jeff?
Yeah, if there's some questions from anyone.
Stuart, last week the Clean Energy Regulator released some figures showing that Australia, in terms of projects, renewable projects over 100 kilowatt, the capacity was more than Hazelton. There's no doubt that renewables are causing significant disruption. Where do you see that disruption occurring in terms of generating baseload power in the next decade?
Yeah, very good question, and one which is much debated, this the B word. One of the areas that our research has led us to is to think that in that very near future, the whole concept of what is and is not baseload is going to change, or has already, if not already changed. And one of the reasons is that we have a very strong focus on the supply and the fact that renewables, whether they be wind or PV, or now the first solar thermal station, although that's got storage, so it's dispatchable, that they're variable, and therefore how will the grid cope with increased variable supply? Now, when you look at the actual grid system, you see that there's just as much variability in the demand, and it can be quite rapid and it can be quite disruptive. In fact, and as we've seen, many of the times when we've had severe outages has actually been driven by those hot February afternoons. So when you look at it from that point of view and say, well, what would we need to do to have the grid operate to provide the services, reliability, if you were to throw the variables up in the air? And the answer comes back that the cheapest way to get dispatchability in the grid at the moment is actually demand-side response. So it's the ability to marshal and aggregate a huge range of different demands. In fact, Australia was like, is such a success story, exactly analogous with dual flush toilets. We were some of the originators of the off-peak hot water system, you know, the direct load control using a frequency injection relay to control hot water systems. Now it seems very old tech, but at that time in the 70s it was very high tech. But you take that out to air conditioning compressors, and there's been many successful trials, pool pumps. There's a whole range of, including vendors in the market currently. And the government has finally woken up to this, and so AEMO and ARENA, some of you may know, have had a trial last summer, the summer just gone, where they put out to the market for 100 megawatts of demand-side response, and they were so inundated with responses at a lower cost than they expected that we actually have proved that there's a much more mature market. So that's the future. We will start to see demand-side response in the market providing the backup for reliability cheaper than gas. I mean, gas is obviously the last resort. I don't know if I've quite answered the question, but that's part of it.
Thanks, Professor. Very interesting presentation. I note that in your presentation it was really only in the first section where you talked about unmanaged water that you talked about health, or you mentioned health. And of course health aspects of plumbing is something that's been pretty important to a lot of us in this room going forward. And surely where you're managing water and waste, it's an ongoing issue. But it doesn't seem to take much of an impact make much of an impact in your presentation here, and so I'd be sort of interested in some perspectives on that. But the other thing I'm wondering, given the changing world as it is, and the costs of sewage and infrastructure and so on, have you actually looked at the waterless toilet being developed through the Gates Foundation, and the development of what's called, I think it's the Omni processor, that converts waste to energy and fresh water?
Yeah, good question. Thanks, Stuart. In relation to the second question, it's a shame I should have had a photo of it, but in about 1990, I installed a composting toilet, one of the first in Australia built up in a urban area, because at that time they were really only allowed for bush blocks and the like. And that was in Lismore, and we managed to get permission from Lismore City Council for a trial for a composting toilet, a dry toilet as it were. And again, it's pretty convenient there because, like Brisbane, all the houses are up on stilts, so you can easily get underneath and do that. We're just talking about this over lunch actually, and how the market in the dry toilet hasn't really moved on, and most of it has been focused on less low-income countries. Which I think is a shame. I mean, I think there are huge opportunities for us to push the limits, and I suppose vacuum toilets probably push the limits to the greatest extent. I mean, getting fractions of a litre per flush in a vacuum system, getting a product that you can use in anaerobic digestion without any other additional processing is probably pushing the limits for a large, tall building. So yeah, we've looked at some of the Gates stuff. A lot of them are quite energy intensive, but it's a fantastic thing that the Gates Foundation do to try and get the best out of innovation. And of course, you're absolutely right about health. The importance of maintaining health and not sacrificing it with these processes. Some of the work that we've done historically has looked at the probability of incident if you have a lot of distributed systems. So if you have a lot of distributed systems and one of them goes wrong in the sense that the treatment train, this is in relation to sewage and impacts of sewage, and the spread of likely disease, viral, rotavirus, that sort of thing, compared to if you have a large system and something goes wrong. And it is quite analogous to the work that we did on the Intelligent Grid project, which is that you actually have a greater level of microbial reliability, at least for that modelling and study that we did. So it's actually, I reckon, an open question about the failure and safety of these systems. And of course that work that we did would have been 15 years ago, and I think it's improved significantly since then. And some of you might know Nick Ashbolt from UNSW, who went across to the US EPA and did a lot of this, this work. The other dimension of this, of course, which comes up often and has come up more recently, is Legionella and the potential impact of efficiency on slow movement of water in pipes and so on. And it seems to me, from my analysis of that literature, and it came up a lot in our water efficiency conference in Cincinnati a couple of years ago, is that there are the sort of standards and practices issues that give rise to Legionella in terms of configuration of pipework and dead legs and so on, is probably a greater level than what you might see from the sort of gradual improvement in efficiency. So there's an open question there. And of course temperature is a trade-off with energy as well, but thermostatic mixing valves are probably the best way to solve that.
And I guess that's the point, is that whatever we do, especially if we're dealing with water, there's always a threat of pathogens developing and living in that environment that have an adverse effect on our health, etc. So it seems to me that's a constant. It is a constant in our management of water, irrespective of how efficient and how much technology we apply to that process. And of course, that's an area that we're very concerned about with respect to the watermark certification scheme to ensure products are fit for purpose, and the recent outbreaks of lead in drinking water, particularly in the Perth Children's Hospital and other areas where products have claimed that lead is leaching into the water through the product. So those sorts of things are obviously a constant that need to be monitored and managed.
We might close it there, Stuart.
Thanks.
Thank you, Stuart, for putting that so succinctly together. It's the big issues of town that lead right down to where our markets are, and it's great that you're able to share that time and spend the morning with us. You're most welcome to stay. I know you work on different commissions for different companies that are involved in the plumbing market, and you offer some great services out there, and we should have more interaction going with the UTS.